welcome to the Minitab Express video on how to create a one-way ANOVA on Minitab Express. I just redundant. Yeah. Anyway, so for this example, we're going to be looking at paint hardness separated into 4 different blends, and we're interested in seeing, on average, does one of my blends have a different hardness than the other? And that's exactly what our null and alternative hypothesis need to look like. So what we're really saying here is I'm measuring a quantitative variable across several different groups where I have a categorical variable that's being used to make those groupings. So since I have more than 2 samples that I'm looking at, or more than 2 types of blends of paint, I cannot use a 2-sample test. We need the ANOVA for this. So I'm just going to go ahead and write my hypotheses, equation, symbol. So I'm saying that my mean hardness for blend number 1 is the same as my mean hardness for blend number 2, is the same as my mean hardness for blend number 3, is the same as my mean hardness for blend number 4, or all my means are about the same, or are the same. So saying that blend didn't make a difference. They all came out with the same average hardness. And your alternative is always one of these things. It's not like the other. At least one blend is different. All right. Just gonna make that different color real quick, or not at all, because this is going so well. So up next, I'm going to perform the one-way ANOVA so that you can see how this is done on Minitab Express. So I've already clicked onto the Statistics tab. From here, you want to go to Analysis of Variance, what ANOVA stands for, ANOVA, and then we're going to go over to the one-way, since that's what we're looking at here. So it's asking you, what's your response, or what are your categorical values, and are they all in the same thing, separated by a specific factor? And yes, they are. So I'm going to go ahead and put a hardness in there, and then use the factor of paint to decide if my hardnesses are the average the same. Normally what I do is I just hit OK at this point if all I needed was the ANOVA, but I kind of want to check some of my why am I drawing a blank on this? Requirements? Conditions! Yay! Conditions for using the ANOVA. So I'm going to click on the Graphs tab, and I want to add some additional tabs to this. So I like to have the box plot in here and the residual plots. Normally what I just select the one I need off of the residual plots, but I'll just take all of them for fun. Additionally, there's something else I want to do to this, but I'm going to wait to do it until after we do our initial ANOVA. So I'm going to go ahead and hit OK. And it should produce a bunch of graphs and a bunch of outputs. I'm going to make this a little bit bigger. So there we go. So there's our ANOVA. I'm just going to copy it over, the ANOVA output. And I've got some other model summary things. It produces confidence intervals, which are kind of nice to look at because you can look at this and be like, oh, well, these all overlap, so confidence interval is enough for you to be able to tell if they're different or not. Although it appears that blend 2 is pretty low compared to everybody else. The same with blend 4 is pretty high compared to everybody else. Blend 1 and blend 3 look almost identical, which is interesting. You know. And here's what I'm really interested in. I want to look at the box plot. Clearly, all their means are different, since, you know, you can see them at the center. But the other thing that's a little concerning to me is clearly this sort of, these blends have different size boxes, aka the distance between Q3 and Q1 is different. So 2, 3, and 4 aren't too different from each other, but blend 1 has much larger variation as compared to the others, so that's very concerning to me. I think this will violate the equal variance condition. I'm going to scroll down further. So there's versus fit. I don't really care about that one so much. That's usually the versus fit one is really not so useful to read when it comes to an ANOVA at all. Just so you're aware. Versus order is the same. What I really want to look at are the bottom two. So the normal probability plot, most of this is pretty close to the normal line. It does have some curving to it, and that's a little concerning, but it definitely meets the nearly normal condition. If you scroll down to the histogram, it's harder to see that because the way it's chosen, this binning doesn't make it very easy to see. So if you wanted to, you could adjust the bin value and make it smaller to hopefully make this a little bit easier to see. At the very least, this looks fairly unimodal and maybe a little bit symmetric, but not completely. It definitely doesn't look it doesn't look very symmetric, but it appears I've meet the nearly normal condition by looking at the normal plot. And I suggest you look at this one because it's a little bit easier to read, I think, when it comes to the ANOVA results. All right. So next up, what's my F statistic? Well, it's right there. 6.02. And then what's my p-value? Well, it's pretty darn tiny, 0.0043. And in particular, for this example, I believe we were using 1%. I'm going to scroll up and check. Yep, we're using 1%. So since my p-value is under 1%, we are definitely going to be headed towards rejection land. So that's what we want to say. The evidence suggests that the average hardness is different for at least one of the blends. At the 1% level. I'm just making note of my level as my evidence. Okay. Now, this is a very dissatisfying conclusion because you look at that and you're like, well, which one of them's different? I mean, you can look at the confidence interval and tell yourself, well, they overlap, so that doesn't help me at all. They all have something in common, so they all look pretty similar, so who's the one who's different? And that's where we need the post hoc test to tell us, hey, now that I know there's at least one that's different, how can I tell which of these is the one that's different? So we're going to go back to the analysis of variance, the ANOVA, and then to the one-way ANOVA. Keeping the same setup, so I want to measure hardness against paint, and then I'm going to hit the comparison button. This is how you can produce a post hoc test that will compare these values. So I'm actually going to use the Tukey test because it's my favorite, and I think it's one of the easier ones to read and understand what it's doing. And it also just does pairwise multiple comparison to do this. So it's going to go through and produce some extra stuff now because I asked it to do the Tukey test. And this is the part that I want, the grouping information. So I'm just going to put this below my conclusion so you can take a look at it. So the Tukey I think I like because it's usually fairly easy to read. It doesn't take somebody who has been doing this for forever to be able to understand what's going on with this test, because it literally describes what it's doing right below. Means that do not share a letter are significantly different. So blends 1 and 3 are similar because they share letters. Blends 1, 3, and 4 are similar because they share letters, and blends 1, 2, and 3 are similar because they share letters. And that tells us that blend 4 and blend 2 are significantly different from each other and not as similar to each other as blend 1 and blend 2 are, which is something that the other test couldn't really tell us because it just looked at it and said, oh, these overlap, done. So really what we're going to be able to say is not only are they different, but you can now say who has the best hardness or the largest hardness, if that's what you're interested in. Maybe you wanted it softer, in which case you would report blend 2, but if you wanted it harder, you report blend 4. So I'm going to report blend 4 as being harder than the rest of these, and blend 2 is being the softer. Was blend 2? It was blend 2. Okay. So additionally, we note that blend 4 is significantly harder than the other blends. There. Now if we'd been looking for a softer blend, I would have been talking about blend 2 and it being the softest of all of them. So you just got to kind of keep in mind of what you're trying to say with your data and what you're trying to investigate. Yay! Now below this I also have some descriptions of residuals in case you forgot, and you know, some things for you to look through if you are interested in it. That's all for today. Hope you enjoyed. Tukey Tukey.